So we start, question 1, we're going to start with this proof by induction, and we're only doing the third part for n equal to k plus 1. So remember, what we have to do is we have to add the k plus 1th term to the left side, which means taking the nth term there and substituting k plus 1 for n. And on the right hand side we're going to add the same term, but we can try to simplify it. So we're going to add the k plus 1th term to both sides. So we've already said in step 2, assume true for n equal to k. So therefore that's where we've got this part back there and that formula. So we're following on from having that with k instead of n in the third part. There's the k plus 1th term. We've taken k plus 1 and we've substituted for n. And we add the same onto that side. The only difference is I've simplified the k plus 1 plus 1. Now that's where we need to end up, because we need that formula with k plus 1 over k plus 1 plus 1. Now if it's pretty complicated, then we can go backwards. We can say, well, let's take that, and in rough, spelled R-U-F-F of course, we're going to take that, substitute k plus 1 and work it till it's as simplified as possible. We're going to work this until as simplified as possible, and I hope that the two meet up so that we can follow back up the other way. So we're aiming at that. So all we're going to do now is go algebraic with this all the way, hopefully, to get that. So common denominator. Multiply out on the numerator. Factorize the numerator. Cancel the k plus 1s. And there we are. There's k plus 1, and k plus 2 is k plus 1 plus 1. So we can say true for n equal to k plus 1, and we've finished with step 3. Now this is a bit of guesswork in some ways, I guess. Remember that these are composite functions, f of g of x. So we take f of x, and whatever g of x is equal to, we substitute for x in f of x. Now the best way to start is to try to look at patterns. This already has g of x in it, so it's not f of x, it's f of g of x. So I'm going to first take this f of g of x, and I'm going to factorize x squared minus 2x plus 1, because I see a glimmer of hope. So there we are. Now if you have a look at this, there's a pattern. Hopefully you see it. 1 over something plus that something squared. That seems like that's the f of x. So f of x is likely to be 1 over x plus x squared. Now let's have a look at this g of x equals minus 2. Now if it's going to fit in, that means g of x would have to equal x minus 1. So let's try g of x equal to x minus 1 and find g of x, just to test it. So if g of x equals x minus 1, then g of x equals, and I'm going to take g of x minus 1, and I'm going to substitute for the x. There it is there. We end up with x minus 2, which, aha, is equal to x minus 2, which makes that true. So now we have f of x, which is 1 over x plus x squared, and we have g of x. So now we have to find g of f of 2. So we're going to find g of f of x first. So g of f of x, what I'm now going to do is take g of x, and I'm going to put the f of x in instead of x. There it is there. Now, in order to find g of f of 2, it's a case of simply substituting 2 into this formula. And we get 3.5. You should recognize this sort of question from your core maths algebra, core maths calculus, because this is virtually what it is throughout. It is really from core maths. The only difference is it has exponentials in it. So P of t equals 120 e to the negative 0,0079 t watts. We have to determine the electrical power initially produced by the generator. Well, initially t is equal to 0. So therefore, let's substitute 0 for t. There we are. And that gives you 120 e to the 0, which is 120. So there's your initial power. Calculate how long it takes for the electrical power produced by the generator to reduce by 15%. Now, if it reduces by 15%, that means it has to reduce to 85%. So now, that means that, if you hear noises in the background, that's just my very busy wife cleaning the house. She's amazing. Anyway, back to this. We're going to say reduced by 15%, so therefore the power is now going to be, there's the power, and it's going to be equal to 85% of what it was. So there's the power, and it's equal to 85%, which is 0.85 of what it was at the start. Solving. We end up with 102 divided by the 120. Now, in order to go further, we need to go to logarithmic form. Remember, the log is the exponent, so that is equal to the log. There's the base of the log, so there's the number. That is equal to the log to base e of that number. And log to base e is ln. So that equals ln 102 over 120. That's log to base e. Now we use our calculator. 20.6 minutes. Part 3. Calculate the rate in watts per minute at which the power is decreasing at 20 minutes. Now the rate, remember, rate of change is the derivative. The derivative is rate of change. Derivative is the gradient, derivative is the rate of change. So we need to take pt equals that, and we need to differentiate it. Now, this isn't just a straightforward derivative because we have a function inside a function. This is a composite function. The outside function would be 120 e to the x, and the inside function is that exponent part, y equals that exponent part. So therefore, we have to use chain rule, which is derivative of outside times derivative of inside. Now, derivative of e to the anything is e to that something coming straight back at you. So therefore, it's equal to 120 e to the negative 0,0079 t. There we are. But we have to multiply by derivative of the inside. That's derivative of the outside, leaving the inside as it is, times derivative of the inside. And derivative of negative 0,0079 t is negative 0,0079. Substituting the 20 for the 20 minutes, and we end up with 0.81 watts per minute. Here we have a logarithmic graph now. Asymptotic to some amount. The asymptote occurs when ln becomes undefined and ln of 0 or below 0 is undefined. You cannot have log of a negative number. You cannot have log of 0. So now, first one, determine the axis intercepts. correct 2 decimal places if necessary, and the equation of the asymptote. So the y-intercept is when x equals 0. So let's substitute 0 for x. And we end up with 3, because we have ln of 1, which is 0. X-intercept, equate the right-hand side to 0. And we need to solve that. So, ln of x plus 1 equals negative 1, 5. X plus 1 equals e to negative 1, 5. There we are, and we're going to use our calculator from there. Sorry about the background noise, but that is my very busy wife cleaning the house, and I'm not going to stop her doing that because she works non-stop. She's amazing. Right, now we have to find the asymptote. Remember I said just now ln of 0 or less than 0 is undefined. Sorry, now I have hiccups. Anyway, so therefore it's when this becomes 0, which is at x equals negative 1. Yeah, x plus 1 equals 0, x equals negative 1. And there is our asymptote. Find the inverse function of f of x equals 2 ln x plus 1 plus 3. Writing it in the form f minus 1 of x equals. Well, to find an inverse function, we swap the x and y. We have y equals 2 ln x plus 1 plus 3. So now we're going to write x equals 2 ln y plus 1 plus 3. And we're going to solve that equation back for y. To go from there, we need to go to exponential form. The ln logs are exponents, so there's the exponent. The base is e, so therefore we know we're going to have e to the x minus 3 over 2, and it's equal to y plus 1. There we are. And therefore y equals, and we substitute the 1 on the other side, and there is our function y equals, so that is f minus 1 of x. We're into the derivatives. Determine f prime, g prime, h prime. Now let's have a look at this. Not many people handle this very well at all. That there is a function of an inside function. It's a composite function. It needs chain rule. Sine of tan of 2x. The inside function, the outside function is sine. The inside function is tan of 2x, and there's another inside function there being 2x. So if we're going to find derivative of sine of 2x, derivative of the outside is cos, and leave the inside as is, times derivative of the inside, so derivative of tan is sec squared, leaving its inside as is, so therefore sec squared 2x, times derivative of the inside, and derivative of 2x is 2. Let's go through that again. This is a composite function. It's a function of a function. It's actually a function of a function of a function. Chain rule says that a composite function is equal to derivative of the outside times derivative of the inside. When you do derivative of the outside, the inside stays the same. So we have outside sine, inside tan. Derivative of sine is cos, derivative of tan is sec squared. So therefore we're going to say cos, and we leave the inside the same. There's derivative of the outside. Now there's the inside, and that's going to be sec squared of 2x, sec squared of 2x, and multiplied by the derivative of 2x, which is 2. G of x I don't know if anybody realized you could just multiply this out. Don't do it as a product or anything else. I'm going to multiply it out. So therefore, that's just simplified. I'm going to say x to the 2/3 times x gives you x to the 5/3. X to the 2/3 times x to the quarter gives you x to the 11/12. Now quite simply, 5/3 x to the and subtract 1. 11/12 x to the and subtract 1. And there is the derivative of that, what was a product, but we can multiply out. H of x equals 2x over cos 2x. Well, that is a quotient rule. Derivative top times bottom minus top times derivative of bottom over bottom squared. So therefore we'll have derivative of 2x, 2 times the bottom, cos 2x, minus the top, which is 2x, times derivative of the bottom. And that is a chain rule. Derivative of cos is minus sine, so we get minus sine 2x, leaving the inside as it is, times derivative of the inside 2, all over denominator squared, which simplifies to that. Now we have to arrange f of pi, f prime pi, g prime 1, and h prime pi by 2. Now I hope that these radians don't scare you, because remember 2 pi, 360 degrees, pi, 180 degrees. So therefore this is really just f prime of 180 degrees if you really find it difficult to work just in radians. G prime of 1, h prime of pi by 2. So f prime of pi, we're going to substitute pi for x in f prime, and what's the difference between that and this? I don't think anything. Which now, if I substitute in tan of 2 pi is tan of 360, which is 0. So this whole thing inside the tan becomes 0 inside the cos. So 2 cos 0. Sec squared of 2 pi, you can actually use your calculator to do them too if you really worry, but remember to have your calculator on radians and remember to switch back. So we end up with a value of 2. G prime of 1, so I'm going to substitute 1 in there, and we end up with 2 7/12. H prime of pi by 2, 90 degrees if you want to go to degrees. And notice I have pi because it's 2x, quite useful, which ends up with -2. So there we have it. We need it in descending order, so there's the biggest, G, there's the next, F, and there's the next, H. Find dy by dx if y equals. So now, this involves quite a bit of simplification. Well, not too much to start with, but I'm going to write this as x to the 1/3. But this is a product rule. So therefore I need to use the product rule, and this, when we differentiate it, we have to use chain rule. Outside function cos, inside function x squared minus 1. So therefore, x to the 1/3 becomes 1/3 x to the minus 2/3. That's derivative of the first times the second as it is, plus the first as it is times derivative of the second. Outside function cos, so it becomes minus sine, and the inside stays the same, then multiply by derivative of the inside. Next one, if y equals that, then dy by dx equals that. Write down the values of m and n respectively. Or quite simply, that means differentiate y equals that and compare and see how to work out the values of m and n. So, that there, we're going to write as with like that. We could use the quotient rule, I guess, but it would be crazy. Right, so minus, this is 4x plus 3 to the half, so therefore 4x plus 3 to the minus half on top. That is a composite rule. Outside, minus something to the minus half, inside 4x plus 3. So therefore, the outside, minus half times minus gives you plus half, 4x plus 3, the inside remaining the same, to the minus 3 over 2, multiply by derivative of the inside. Which, if you look at that, that means, I've jumped steps I guess, but on the top line we'll end up with 2 because half times 4. This will jump to the bottom, so we'll have 4x plus 3 to the 3 over 2 on the bottom, so therefore n is 3 over 2. Given sine of y plus cos of x equals minus 1, and that is the case between 0 and pi by 2, just to remove technicalities. Now, dy by dx. This here is implicit differentiation. Have a look at it. We have a y and an x together. Sine of y is a composite function. The outside function is sine, the inside function is y. So when we deal with the derivative of the inside, we have to write dy by dx or y prime. So, outside function, cos of y, multiply by derivative of the inside, dy by dx. Outside sine, so it becomes cos, and inside stays the same. Inside function y, we have to differentiate, so dy by dx. Minus sine of x, there's the derivative of the inside, minus sine of x, equals 0. Derivative of 1 is 0. And we solve for dy by dx. Now we have to find the gradient of the given curve when x equals pi by 3. That's 180 over 3. It's really 60 degrees. Not that I really prefer not to keep going to degrees, but I know that you're all used to that, so keep it in mind. Or you can use your calculator on radians. Don't forget to put it back to degrees afterwards. So I'm going to substitute pi by 3 into the original, because you see the gradient of the curve, I need to know the value of y. See, it's straightforward. The gradient of a given curve when x is that, so we just substitute x, but the problem is we have a y in the derivative, so we're going to have to substitute into the original to find the y value. So cos of pi by 3, cos of pi by 3, cos of 60, I hate to do it, but cos of 60, half, and therefore sine of y equals a half, sine of 30 degrees is a half, which is pi by 6, 180 over 6. Now we have the x and y value, pi by 3, pi by 6. We have the derivative, so we can substitute. Sine pi by 3 over cos pi by 6. Root 3 over 2, root 3 over 2. Doesn't say, oh, it does say without calculator. So you have to show, if you don't show these, then you lose marks. The root 3 over 2, because that is the special angle, which is 1. So here we go. This is going to be another implicit differentiation I can see immediately. Showed that the point 1, 2 lies on the curve. Now when you show that the 1, 2 lies on the curve, you should officially, strictly speaking, go left-hand side, right-hand side. So left-hand side equals. Now I'm substituting 1, 2 into this left-hand side, which gives you 5, which is equal to the right-hand side. And that's the correct way to go about it. You shouldn't really have substituted, have that equals that, that equals that. Aha, at the end it is equal. Determine an expression for dy by dx. So I'm going to do implicit differentiation. That's simple. X cubed, 3x squared. That one there, y cubed, well, that's a composite function because the outside function is y cubed, the inside function is y. So therefore we have to have derivative of the outside, which is 3y squared, times derivative of the inside, which is dy by dx, or y prime. And this one we're going to have to use product rule, and I'm going to put it in brackets because of the minus especially. And remember that this y squared is once again a composite function for chain rule. So there we are. 3x squared plus 3y squared, the outside function, times y prime, the inside function. The outside function differentiate and the inside stays the same. And then you differentiate the inside. Minus. Now, there in fact I've already put it in brackets in my mind, so it's minus, and the derivative of the first, 1 times the second, so therefore y squared. It's then minus plus, so it's minus the first, which is x, times derivative of the second, so you get 2y, and times derivative of the inside, y prime. I'm going to solve for y prime. So I've taken non-y primes to the right, common factor y prime, and there we are. You might have a slight variation with sign changes. You could have 3x squared minus y squared over 2xy minus 3y squared. You could have negative of 3x squared minus y squared over that denominator. Hence determine the equation of the tangent to the curve at the point 1, 2. Well, all we have to do is find the gradient. There it is. Now we use y minus y1 equals m, x minus x1. And there are the x and y values. There's the x, there's the y, so that's 1, that's 2, and we substitute the 1/8. And there's our equation. Right, now this is a maximum minimum question, no different from your core maths, other than the fact it has a more complex differentiation. So as soon as you see maximum number of visitors, you say, well, that means derivative equals 0. So there's c of t. I'm going to differentiate it. So now that is a product rule, and there's a chain rule within it there. So therefore the product rule, derivative of t is 1 times the second. So derivative of the first times the second. So therefore just 1 times 1 minus t to the half. Plus the first, which is t, times half times 1 minus t to the negative half. There's derivative of the outside. Leave the inside exactly the same. Times derivative of the inside, minus 1. Which I'm going to solve. Now the easiest thing to do here is to multiply through by 2 to get rid of the half. 1 minus t to the minus half. Because then we end up with that. Do we? That I should have said multiply through by to the plus half. Sorry about that. That should be multiplying through to the plus half there. Silly idiot. Because then we get 1 minus t to the 1 multiplied by the 2. And here we get t over 2 multiplied by 2, which gives us t. And 1 minus t to the minus half times 1 minus t to the plus half gives you t to the naught. Solving, we get t equal to 2/3.